Okay, so this is Algebra 1, Semester 2, Chapter 9.5 and 9.6, completing the square and the quadratic equation and the discriminant. You will not like this section. So completing the square is a situation where you don't have a perfect square and you can't really get it by factoring. Um, uh, Completing the square is sort of like turning it into a perfect square and then adding whatever you needed to turn it into a perfect square on both sides. So if we have a situation here where we don't have a perfect square and we cannot factor, we use this particular formula. So if we had x squared plus bx, notice there's nothing in front of that x, right? So there's a 1 here. We can use the expression b over 2 squared. This b over 2 squared will help us complete the square. And what happens is when you get this particular number, you're going to add it back on both sides. This b over 2 squared, you're going to add it back on both sides and then do some math, and then you'll be able to find out what the solution to x is. Another thing to note, when we get a square root of a number, this is to recap, it is going to be plus or minus 2, right? It's not just going to be 2. Why? Because there's always two roots. 2 squared equals 4, negative 2 squared equals 4. So we can get to 4 positive both ways, by squaring the 2, by squaring negative 2. So when we do a square root of a number, we're always going to have 2 roots, 2 zeros, 2 answers. And we're going to utilize that fact in this particular section. We're going to use the fact that when we square root a number, you're going to get 2 answers. Alright, so the heck is this? Guess it's going to be that type of day. Okay, so for got it number 1, they're giving us an x squared plus 20x plus c, and they want us to find out, hey, what's the c such that I can complete the square? So to see that that completes the square. Alright, so we're going to do that b over 2 squared. In this case, our b term is 20. So it's going to be 20 over 2 squared. So that's going to be 20 divided by 2 is 10. So it's going to be 10 squared, so it's going to be 100. Okay. So when we complete our square, our answer is going to be x squared plus 20x plus 100. Something to note, well, I mean, this is what they want me to find, but I can, since I have a perfect square here, this number inside of the parentheses, the b over 2, that's 10, right? This 10 is going to be the number that I use to complete the square. So x times x is x squared, 10x plus 10x is 20x, 10 times 10 is 100. So the c is 100, and when I write it as a binomial, that thing that the number that I got from the b over 2, not the squared part, but the b over 2 is going to be the number that I put in here for my perfect square. So for got it to A, they give me that they give me x squared plus 9x plus 15 equals 0. This is not a perfect square. So we're going to have to find the perfect square. The first thing we're going to do is add 15 to both sides, which gives me, or subtract rather, which gives me x squared plus 9x equals negative 15. Now we're going to complete the square. Remember we said that completing the square has to be b over 2 squared. In this case my b is 9, so it's going to be 9 over 2 squared. We're squaring the 9 and we're squaring the 2, so 9 squared is 81. And 2 squared is 4. So when we write my perfect square, this number 81 over 4 is what we're going to add to both sides. So it's going to be x squared plus 9x. And what we're adding to both sides is 81 over 4. Negative 15. Okay. This is what we're adding to both sides. Why are we adding it to both sides? Because we want to complete the square. Remember what I said, that in the middle of this term here, the 9 over 2 inside the square, the b over 2, is going to be the term that I use to have my perfect square. So this is going to be x plus 9 over 2 times x plus 9 over 2. And that makes sense, right? Because 9 halves times 9 halves gives me 81 fourths. So I feel confident in that. And then if I add 9 halves plus 9 halves, that's 18 over 2. 18 divided by 2 is 9. So that makes sense too. So I rename this as x plus 9 halves squared on that side. On this side, this negative 15, I'm going to rename it. I'm going to multiply top and bottom. I'm going to put this to the side by 4. Uh, 15 times 4 is 60, so this is going to be negative 60 over 4 plus 81 over 4. I'm going to add these two guys and I get x plus 9 over 2 squared equals 81 take away 60 is 21 over 4. Then I'm going to square root both sides. I'm about to run out of space. Okay, so after I square root both sides, that square goes away. I'm going to have x plus 9 halves equals, so since I'm square rooting both sides, there's going to be a plus and minus here. So here's how I attack these. If I can't get a perfect square in the top, I'm going to leave it alone, or a perfect square root. But I could square root that 4, so I'm going to leave it as plus or minus the square root of 4, which is 2. So x plus 9 halves equals plus or minus the square root of 21 over 2. So then the next thing to do to find my x is going to be, on the plus side, square root of 21 minus 9 over 2, or it's going to be negative the square root of 21 minus 9 over 2. Depending on who your math teacher is, and if the book doesn't say they want it to specific decimal, but it looks like they do, they want it to round it to the nearest hundredth, they would stop right here. But the book wants you to round it to the nearest hundredth, so square root of 21, I'm using my calculator, minus 9 divided by 2 gives me approximately negative 2.21, or negative square root of 21 minus 9 divided by 2 gives me negative 6.79. And that is my answer. You're going to have two answers for these to complete the square. So this is a lot. First thing you're going to do is, since this isn't a perfect square, subtract the 15 on both sides, then it gives you x squared plus 9x equals negative 15. We're going to use our equation, our expression, b over 2 squared. B is 9, so it's going to be 9 over 2 squared, which gives me 81 fourths. It's going to be this 81 fourths that we're going to add to both sides to complete the square. Whatever your b over 2 term is going to be the second part of your binomial. So it's 9 over 2. So this is going to be x plus 9 over 2 times x plus 9 over 2, which is x plus 9 halves squared. I multiplied negative 15 top and bottom by 4 so I can add the fraction, 81 fourths, which gives me 21 fourths. I square rooted both sides. There isn't a perfect square for the square root of 21, so I left that alone. And then there is for square root of 4, which is 2, so I left it as plus or minus the square root of 21 over 2. Then I subtracted 9 halves from both sides for the plus 21, square root of 21 over 2, and the minus square root of 21 over 2. And I got negative 2.21 or negative 6.79. Completing the square can be very, very messy. So this thing is asking about finding the vertex. I'm not going to have you guys responsible for that, so don't worry about it. So this is an example of, and I'm going to sort of copy the book's example here. I'm not going to ask you to do a word problem with this, but the process is going to sort of be the same. So what happens if you have something in your A term? So I'm not going to do this part. I'm just going to go straight to here. So we have a 3x squared plus 8x equals 96. So this is a little bit different because the first problem that we did, we had nothing in the A term. This still works, but the way that we're going to do it is going to be a little messy because we're going to divide out that A term. We're just going to divide everything by whatever the A term is. So we're dividing everything by 3. This cancels out. This turns into x squared. This turns into 8/3 x. This turns into 32. Now this is in a form that we can do our to find our completing the square term. So remember that it's going to be b over 2 squared. In this case, it's going to be 8 over 3 over 2 squared. This is a complex fraction. I've multiplied top and bottom by 1/2, so this turns into This turns into 8 over 6, which simplifies into 4/3. So this turns into 4/3. I'm doing mental math. But it's going to be squared. So this is my b over 2 term, 4 over 3. I square the 4, I square the 3, and I get 16 over 9. So it's going to be this 16 over 9 that I'm going to add on both sides. Box this right here. It's going to be that 16 over 9, so it's going to be x squared plus 8/3 x plus 16 over 9 on one side equals 32. And let me multiply that 32 top and bottom by 9 so I can make this work better for me. So that's going to give me 288 over 9 plus 16 over 9. So I multiplied 32 top and bottom by 9 so I can add the fraction 16/9. It makes life easier for me. So remember this term here, this b over 2 term, that's going to be the term that's going to be my completed square. So it's going to be x plus 4/3 squared. X times x is x squared. X times 4/3 is 4/3. 4/3 plus 4/3 is 8/3. And then 4/3 times 4/3 gives me 16/9, so that works. 288 plus 16 is 304. So this is going to be 304/9. Then we got to square root both sides. Those two cancel. I have x plus 4/3 equals plus or minus the square root of 304. I can square root that 9, so that's going to be over 3. So let me explain how I'm doing this for those who might be like, what, I shouldn't be over. If I square root the whole thing, this means that I square root the numerator and denominator individually. Well, this doesn't give me a perfect square, so I'm just going to leave it as it is, which is why I leave it as it is. I'm going to wait till the end to do the math so I can get my decimal later. No sense in me doing this now because I know that since it's not a perfect square, it's going to be an irrational number and it's going to go on forever. So I'm going to save that calculation to the very end. But I can do the square root of 9, and that gives me 3. So I leave the top alone, I square root the 9, and I get square root of 3 over 4 over 9. So that's where that number comes from. So once I get here, I just have to subtract the 4/3 from both sides. So for the plus side, it'll be square root of 3 over 4 over 3. Oh, another note, just to show you where I am shortcutting. So square root of 3 over 4 over 3 minus 4/3 is the same thing as saying square root of 3 over 4 minus 4 over 3. Why? Because they have the common denominator. So I'm skipping that step. So 3 over 4 root minus 4 over 3. Or on the negative side, negative 3 over 4 root minus 4 over 3. Then I'll do my square root. And on this side I get 4, rounding to the nearest hundredth, 4.48. And on the other side, I got negative 7.15. Book is wrong. Okay. I'm going to go with my answer because, you know, I'm the best. And that equals x. Okay. It's long. It's cumbersome. I'm not going to lie to you. Completing the square, probably of all the factorings of that people do, is probably the particular process that people hate the most. So another example, because I think it's good to have two. Again, the book gives you that word problem, but we're not going to do the word problem. So what I'm going to do is, it says the border is 150. I'm not going to do this one. I'm going to do this one right here. So I'm going to do 4. And how do you know how? So for this one, I have 2z squared plus 3z equals 135. Already looks messy. I'll make this a little smaller. I'm going to try to write small. Good luck to me. Alright, so remember we don't want anything in that a term, so we're going to divide this whole thing by 2, which renames it z squared plus 3z half equals 135 over 2. I'll keep the 135 over 2 for right now. So, remember, b over 2. Actually, let's just go straight to the b over 2. So that's going to be, the b term is 3 halves, so it's going to be 3 halves over 2. That whole thing is going to be squared. Multiply top and bottom by 1/2. So that turns into 3/4 squared, which is 3 times 3 is 9, 4 times 4 is 16. So it's going to be 9/16. It's going to be that 9/16 that I add on both sides. So this 135, I'm going to multiply top and bottom by 8. So z squared plus 3 halves z plus 9/16 equals, again, I'm going to multiply this top and bottom by 8. And that gives me 135 times 8. 1080 over 16. And I'm going to add that plus 9/16. I'm adding it on both sides. That b over 2 term is 3/4. So when I write my binomial, it's going to be 3/4. That's very convenient. 3/4 times 3/4 is 9/16. 3/4 plus 3/4 is 6/4, which simplifies to 3 halves. That makes sense to me. This is 1089 over 16, and I'm going to square root both sides. these two guys cancel, so I get z plus 3/4. This guy is the square root of 1089 over 16, which gives me 33 over 4. Hallelujah. Plus or minus. So on the plus side, it's going to be 33 plus 3 over 4. Or on the minus side, it's going to be minus 33. Whoops. Minus 3, I'm sorry, over 4, and then minus 3 over 4. So this is 30 over 4. Which simplifies into top and bottom to 15 halves. So it's going to be 15 halves. And then negative 36 over 4, and that simplifies into negative 9. And that is x. So x equals either 15 halves or negative 9. Alright, so that's that section. Again, it's not a fun section. Everybody hates completing the square. Alright, so the discriminant and the quadratic equation, or the quadratic formula. So the quadratic formula, I would be a good idea for you to memorize it for your high school career. You're going to see it. You're going to see it in Algebra 1, definitely Algebra 2, definitely pre-calculus, calculus, and sometimes you'll see it in geometry. So it's best just to memorize it. So to find x, and this is the formula that most people use, is that instead of completing a square, people use this thing. Negative b plus or minus 4a, b squared minus 4ac square root all over 2a. This is what people use most of the time to solve their problems. You just plug in the thing and then you get your number, as opposed to that completing the square thing where, hey, sucks. Alright, so they show you a proof as to why it works. I'm not going to show you why it works or the proof. That's not necessary, but it definitely works. And it sort of has to do with completing the square. And what they do in this case is that's exactly what they do. They complete the square. And by completing the square, they do some finagling, and you get your quadratic equation. So it definitely works. The quadratic equation is actually a fancy form of completing the square. Alright, so to use it, really straightforward. It's basically plugging it in and solving. So for the first one, we get x squared minus 4x. It says equals 21. I'm going to subtract that 21 on both sides and equals 0. Okay. In this case, a is equal to 1, b is equal to negative 4, c is equal to negative 21. You're going to also use those minus signs. Not just the number, but the minus sign. So when I plug it in to my quadratic, x is going to equal negative 4 plus or minus, oh, there's a square here, negative 4 squared it would be a 4. Take away 4. A is 1. And C is negative 21. That's going to be square rooted. And all of that's going to be over 2 times 1. All we do is plug it in. So this is going to be 4 plus or minus 16 is a negative times a negative, so that turns into a positive. 4 times 21 is 84. Square root. 2 times 1 is 2. And it's 4 plus or minus 16 plus 84 is 100. Square root over 2. So then that's 4 plus 10 over 2, which gives me 4 plus 10 is 14, plus or minus. So it's going to be either 14 over 2, or it's going to be 4 take away 10 is negative 6. Negative 6 over 2, which gives me 7 or negative 3, and that's going to equal x. Quadratic, a lot easier than completing the square. We plug it in. Make sure that when you have negative numbers, you plug in the number with the negative sign, otherwise you will be thrown off. You would have had, if you didn't plug in the negative 21, you would have had 21 times negative 4, and this would have been a negative number, and you would not have been able to do this. So remember, plug in not just the numbers, but also the negative signs. Okay. We're not going to do a word problem. Okay, so scenarios in which you can use certain things. So we've solved for x with quadratics by square rooting. We've done factoring. You can solve by graphing, which I don't recommend. So here's a scenario where you can solve just by square rooting. So here there's no x term, right? There's a 3x squared minus 9. Here you don't have to use any quadratics or any factoring. All you have to do is solve for x, right? Add 9 to both sides and square root. Here, this is a perfect square. So you can solve this. You could use the quadratic if you wanted to, but it really isn't necessary because it's a perfect square. It's x plus 5 times x minus 6. So you can use factoring. Here, notice that it has that 6 right there, right? It's not a perfect square. You could factor it, right? Let's see, two numbers that gives you 17 and 13. Nah, not, or not 6 times negative 17. It's possible, but it's actually easier in this case to use the quadratic formula. It says that the equation can't be factored. So since it can't be factored, it's easy just to use the quadratic. To graph it, I would not recommend graphing it. This guy, this is not a perfect square, so you can complete the square. You could have completed the square here too, but it's not recommended. That's messy. Here you can use the quadratic. You can complete the square. You could graph, but I wouldn't graph. Here, same thing. You can use the quadratic. Notice it's quadratic. Everybody uses the quadratic. I mean, nothing is really easy. Nothing is usually a perfect square. So it's always going to be quadratic. That's what everybody uses. Graphing, I don't recommend it. And I wouldn't recommend completing a square. It's huge numbers here. So quadratic, when in doubt. So here, they're asking you to find how you would solve it. They're not asking you to solve it. They're asking how you would solve it. So for A, they give us x squared minus 8x plus 12 equals 0. Um, can I get a perfect square out of this? Yes. Yes, I can. I can get x minus 2 times x minus 6. I'm doing this mental math, right? 2 times -2 times -6 is 12, and then 6 2 and 2 in it, 6 is 8. So I can factor. It's about the only time I can factor. This one for B, this is A. For B, they give me 169 x squared equals 36. I can divide both sides by 169. And then square root. Square root of 36. Square root of 169. I believe that's 6 over 13, if I'm not mistaken. Yeah. So I can do this by square roots. I can just square root the side. So that's that one. And then C. I already see that 5x up there. I see that -1. And I already know there's no number that I can multiply to get to -5 and then sums up to 13. So this is not a perfect square. So I could complete the square, but it's messy. So for this guy, 5x squared plus 13x minus 1 equals 0. I'm just going to use the quadratic. It just makes sense to use the quadratic equation for that one, or the quadratic formula. Okay, so the discriminant. If we look at our quadratic equation, there's a part there. The b squared minus 4ac, that's called the discriminant. And what the discriminant does is that it can tell me how many roots I have. If I have 1 root, 2 root, or no roots. And the way that I can tell if it has that many roots is how I solve it. So if, for case number 1, I really want to get, so in terms of case number 1, I have b squared minus 4ac. This guy is the discriminant underneath the vertical sign. If it is greater than 0, so 1, 2, 3, 4, 5, then I have 2 solutions. If it's greater than 0, then I have 2 solutions. Scenario number 2. If b squared minus 4ac is equal to 0, then I have 1 solution. And then scenario number 3. If b squared minus 4ac is less than 0, then I have no solutions. No solutions. And that's the discriminant. And that's usually helpful for graphing. more than anything. Okay. So let's do one. Alright, so that's my discriminant. So for 4a, they give me 6x squared minus 5x. I'm going to subtract 7 from both sides. Minus 7 equals 0. I'm just going to focus on the discriminant. So remember, this is my b term, this is my a term, this is my b term, this is my c term. Not just the number, but the number and the sign. So negative 5 squared minus 4 times the 6 times the negative 7. That's going to be 25 plus 42 times 4, which is 168, plus 25, which gives me 193. This is greater than 0, so that means that I have 2 solutions. So put, and that's it. That's all you do. Okay, so that's section 9.5 and 9.6. Hope you have a great rest of your day.